We're starting going through page 37, questions 1 through 15, and then we'll just add in the questions from 16 through 35. Like I was saying, these are not Regents questions. This is just practice using the reference table. Monday's test will be more like the homework we went over yesterday. There's a couple different sets of them. So there's mineral questions, igneous questions, sedimentary, and metamorphic questions already in the packet that I would review over the weekend if you're going to study. So I'll just give you the answers. If there's anything on here that you're questioning, let me know. So calcite bubbles with acid, magnetite is attracted to a magnet, halite is a food additive, hematite can be metallic or non-metallic, and pencil lead is graphite. Good. There are two different ones that have a greasy feel. It only asks for one, so talc or graphite. Pyroxene, on the reference table, it says it's commonly called augite. Particle size of 0.001. I do want to talk about that for a second. There's two ways of doing it. One would be to just look on here and realize that 0.001 is in between these two numbers, so that makes it silt. Or another way is to use this reference table. They actually even have 0.001 labeled. Follow that over, and that is in the silt section. So you could do it either way as long as you're using your reference table. Periodite is an igneous rock made of only pyroxene and olivine. Pumice has a low density. Cooled very quickly is extrusive. You could have put on the Earth's surface too. That would have worked. Rock salt is crystalline. Angular fragments of pebbles and cobbles, that's breccia. Diorite and andesite have color, density, composition. They also have their mineral present are the same. Composed primarily of mica, that's slate. Gneiss has all 6 bars in it. So it's made of mica, quartz, feldspar, amphibole, garnet, and pyroxene. Since limestone is made out of calcite, it will bubble with acid. Same with marble. Solidification of magma is igneous. Number 21, compaction and sedimentation is sedimentary. Where are we? 22, directly from other rocks is metamorphic. 0.007, it does say name the rock. So if you put just sand here, I would have to mark it wrong. It is sandstone. Vesicular means the rock has gas pockets or holes. The largest particle listed on the reference table is boulders. Porous rock with a lot of potassium feldspar is granite. Halite makes rock salt. Breaks along flat surfaces is cleavage. When you scratch a glass plate, you're testing for hardness. Shines like a metal is metallic. Contains potassium feldspar quartz, but usually appears black as obsidian. Distorted pebbles is metaconglomerate. Low-grade metamorphism of shale is slate. You would find a layer of contact metamorphism in between a sedimentary and an igneous rock. And I couldn't leave out my favorite piece of schist has pallady mica crystals visible. I know that was super fast, but were there any you got wrong and would like me to double check or go over? What'd you say? Okay. I got one wrong? I got piece of schist wrong? No, I didn't. Oh, I did. I forgot the C. I'm sorry. That is just a case of my hand going faster than my brain. I thought he was kidding too. I'm like, no. I did. Yep, that was just, I think, and honestly, I don't really care how you spell it as long as I can recognize that it's that word and not another word. So yesterday we started the review sheet. We got through all there was to know about sedimentary rocks. We talked about how they're formed. Fossils are only found in them. They're sorted by their texture. The textures are clastic, crystalline, or clastic, bioclastic, crystalline. The clastic rocks, they're sorted by just their grain size. Bioclastic and crystalline are by their composition. We did. This is really important that you remember sedimentary rocks. They're found on the surface in horizontal layers. Then we did everything there was to know about metamorphic rocks, how they change by heat and pressure. They're classified by their texture, which is foliated and non-foliated. And don't forget banding and mineral alignment. We went on to make sure you knew what parent rock was, and that's what the rock used to be before it was changed. And you find that in the comments section. I just want to add one thing that we added in my other classes for metamorphic rocks, and that is going to be the Regents definition. So metamorphic rocks. They will use the terms recrystallization. And they might even say recrystallization of unmelted rock material. And I bring that back to the Hershey bar example. So remember, we start with a hard Hershey bar, a nice solid Hershey bar. And then it gets ooey gooey. That's where they're using the term unmelted. So it's not melted, but it's also not a perfect solid anymore. So the ooey gooey stage. And then when it cools back down, it recrystallizes. It gets harder again. So it's everything you already know, but it's using fancy terms for it. Anytime you see recrystallization, you're going to know that that's a metamorphic rock. What rock did we forget? Igneous, of course. Igneous rocks, how do they form? And what happens to the magma? It solidifies. I do start with the melting and solidification. I just butchered that, didn't I? No, I didn't. Of magma. So it has to melt into magma, and then the magma solidifies into an igneous rock. Perfect. What are our choices for igneous rocks? How do they get classified? By what? Oh, yes, environment of formation. How do I want to do this? Igneous rocks are classified by I'm not gonna be able to fit it all in this box. So we have, we should have just gone with intrusive and extrusive. Intrusive, where are they?
Intrusive?
Intrusive.
Oh, I thought you said intrusive inside.
Inside. Do they cool slow or fast? Slow. And big or small crystals? Big. Okay, so hopefully that all means something. If it doesn't, you'll have to go back to your reference or your Regents, oh my gosh, your packet, and realize that they form inside, they cool slow, and they have big crystals versus extrusive. They cool on the surface. They cool fast. And they have small or no crystals. Sorry, that one, it got messy. We have 5 or 6 types of texture. We have glassy, fine, coarse, very coarse, and then don't forget the vesicular. And if you have room to include non-vesicular. So obviously, we don't have a lot of room to write. What does glassy mean when we're talking about igneous rocks? No crystals. How about fine?
Layers.
Very small. And what does very small mean, according to the Regents? You have to memorize that. Right on page 6 of your reference table. Coarse. They are big. They are between 1 and 10 millimeters. Very coarse, they are very big. 10 millimeters and greater. What's vesicular mean? Yep, gas pockets. And what the heck is a gas pocket? So gas pocket / holes. And non-vesicular? No gas pockets, no holes.
What's Logan do?
That's actually it for igneous rocks for the most part. Everything else for igneous rocks is right on the reference table. So please don't forget that they do include words like mafic and felsic. Just means if you're on the right side of the chart, mafic is rich in iron and magnesium, felsic, left side of the chart, silicon and aluminum.
Children is
Huh?
children.
What?
From the children.
No, yeah, no, we don't have much more to do. Rocks are classified. Rocks in general. So if I just give you 100 random rocks, how do you put them in groups? Those are the 3 groups: igneous, sedimentary, metamorphic. What is that really telling you about the rock? How they form. So rocks are classified by how they form. And if you want to include the 3 types, you can. Igneous, sedimentary, and metamorphic. We started this chapter off at what seems like forever ago with minerals. And the very first time we looked at minerals, we did a 5-part definition. Minerals are, what are they? What do they have to be a mineral? Hopefully this comes back. They can't be organic. They got to be inorganic. Not alive, never was alive, never will be alive. Anybody else remember any of the other ones? Naturally occurring. They have to be inorganic, naturally occurring, and they have to be a solid. And then the other 2 are the kind of weird ones. Naturally occurring inorganic solid with a definite crystalline structure. And a specific chemical composition. Okay, we're almost done. We learned about the properties of a mineral. What are some of the properties we learned about? Luster is one of them. What are our 2 choices for luster? Metallic, non-metallic. What's another?
Hard.
Hardness. That's going to be in its own box. What's another property? Composition is one. I'm not going to put that for a box. It's what it's made out of. Texture. What are our choices for texture for minerals?
Oh, no.
No, no texture on minerals. Cleavage and fracture. Those are the other two that are going to go up here. Streak is also one. I don't know if we need a box for that one though. Uses is not a property, but it's a use. But make sure you check the reference table for its uses. What does metallic mean, according to the Regents? Not shiny, whoever said it.
Who said it?
What does a metallic looks like? Metal. Please do not get hung up on shiny versus not shiny. Non-metallic, what's that look like? Does not look like metal. How about cleavage? What is that? It breaks, and what's it look like? Flat breaks. Or breaks flat, however you want. So the breaks will, where it's broken, so it might not be the whole mineral itself, but where it's broken, the breaks will be nice and flat or straight. Whereas fracture, those are random breaks. Hardness is the ability ability to be scratched. And remember that whatever's doing the scratching is harder. If my fingernail can scratch a mineral, then my fingernail's harder than the mineral. If a mineral can scratch glass, then the mineral is harder than the glass. If it can't, it's weaker. One last box, and that is mineral properties are determined what determines the mineral's properties. So determines their luster, their cleavage or fracture, their hardness. What? No, that is like how we'll test the hardness is using Mohs scale. No, those are the properties. We'll use our observations to see the properties, not the composition. Yep, the way their atoms are arranged, which the Regents will call the internal arrangement of atoms. So, for example, granite and diamonds have very, very different properties. Their hardness is different. Their luster is different. Their cleavage or fracture is different because of how the atoms are arranged, their internal arrangement of atoms. So like I was saying yesterday, despite whether you like these or not, whether they use them or not, I'm making the test, and these are the things that I'm putting on the test. If you were not here or I went too fast and you need to look at this, you're welcome to come on up and take a picture of it. In the meantime, grab either your phone or a computer. We are logging into Kahoot. So if anybody wants to take a picture of this, now is the time.
I watched the videos. I have a picture of it too.
Yes, no, I agree with that statement.
And I like to make it like
Come on. Okay. So you're welcome to work in partners if you want. You will need a reference table out. I should have told you that first. Sorry. here we go. Maybe. There you go. So you'll need a reference table.
Yeah, dollar good.
Yeah, if you're with partners, you can use the same device. It's not that deep today. We just doing some quick review using your reference table. Hey, what did we do? Play Kahoot already? Everybody in who wants to be in? Are we waiting for anybody? Okay, 3, 2, hitting start. Now it'll be.
I think I can guess all these ones.
These are not that difficult here. This is probably a too easy Kahoot, but I bet it's still good. What is the origin and rate of cooling of this igneous rock? There's something very, very particular about it. Just because there are 47 seconds doesn't mean you guys should use all 47 seconds. Just saying. Or we'll use all 47 seconds.
That's right. That one.
There we go. So what about it? First of all, what does volcanic and plutonic mean? Yes, it is right on the reference table right here. Extrusive is volcanic, intrusive is plutonic. And what about it made you know it was volcanic and cooled very quickly? The holes. Vesicular rocks are all extrusive. There is no intrusive vesicular rock.
Usually glassy.
Yes, they are typically glassy. There are 2, vesicular basalt and vesicular rhyolite, that are not, though. A mineral that can scratch A mineral that can scratch sulfur, but will be scratched by feldspar. This one might take you a little bit longer. So first figure out the hardness of sulfur and feldspar. That'll be a good start. Or go by process of elimination. Either feldspar. So a mineral that can scratch sulfur, but can't be scratched by either feldspar. I don't think so. Not if.
It went off my own.
And also it's who, if somebody before you passes up or it was found. And if you literally walked in and walked out, they will see that.
I could show them the camera. I literally
Yeah,
walked in.
they will.
It was like
They'll
first
see.
minute.
They're not, they're not that mean about it. All right, great job. So anyone who said garnet can not be scratched by feldspar. Garnet is way harder than feldspar. So that is not the correct answer. Blank forms when sand is metamorphosed. So give sandstone heat and pressure. What's it turn into?
Yeah, almost like
What the hey?
wow, what the shit? What the shit?
Yeah, that's a good one. Oh
I
man.
said it, the record got.
Oh, you guys are such nerds.
I'm so mad.
I love my little geology nerds using my jokes. Nice, good old quartzite. Guys, shale is not a metamorphic rock for whoever picked that one. Is that you? You picked quartz. Quartz and quartzite are not the same thing. They sound similar, but
No,
which is the only rock that can contain a fossil? Again? What is wrong with you?
come on. Simmer down. I'm gonna go
Take your time on the test, would you?
the rest of these questions without my packet.
Really? That's insane.
Locking.
I haven't had my packet the whole time.
Oh, sorry. We're moving on.
No, just locked.
All right. Which mineral has a greasy feel? Like I said, I think these might be a little too
Oh
easy.
no, I clicked the wrong one. I know the answer.
You too?
Nah, I know the answer. Now, like I guess, and then
It's in my packet.
I know what the answer is. Don't worry. It's
You-
yellow, but I clicked blue. So
It is yellow. Okay, well, I guess you guys have decided we're done reviewing.
Yeah,
We're still doing.
We'll still go. Okay, well, whoever's not clicking, click.
but
I'm
yeah.
clicking.
But if I click skip, it just no one will get their rankings. All right, yeah. Hopefully, those of you who are pick the other ones are not using your reference table. How does nice
Oh,
form?
I'm getting this wrong.
Don't get this one wrong.
Wait,
Is
What is it?
metamorphosis, so.
it's that one.
Just nice.
That one. Oh, this is what it
Well, it's just asking what type of rock it is. It is metamorphic, and how does metamorphic rocks form?
Green.
Yay, heat and pressure. Not cooling and solidification, that's an igneous rock, you silly goose. What determines how a mineral breaks? This is on the test.
Wait, right. I have different.
Wait, yo, it's not
Yes.
top. It might be this one.
Bro, it's red.
Bro, let me lock
Bro,
it.
it's red.
Bro.
I got it.
Okay, this is the internal arrangement of atoms. Hardness is how easily scratched it can be. This, by the way, was describing cleavage or fracture, but it didn't ask cleavage or fracture. It said how to like what figures it out. It's the internal arrangement of atoms. Choose the largest sediment out of these choices.
It's the one with the B.
Yeah, perhaps.
Wait, yeah, it's cobble or pebble.
It's full over.
It's Boulder.
Sand, bro. It's literally sand.
All right, guys, please review a little before the test.
Yeah.
Everybody makes
I did great.
Did you do great? You hit the wrong button on all of them.